kilogram crate is pushed and released down a ramp that is inclined at an angle that equals 30 degrees from the horizontal, giving it an initial velocity of 2 meters per second to the plus x and decelerated to a complete stop covering a distance of 4 meters down the ramp. Letter A, find the crate's deceleration. Letter B, calculate the kinetic frictional force between the surface and crate. And letter C, determine the coefficient of kinetic friction, mu sub k, between the two surfaces in contact. We have here the free body diagram of our situation. This is the crate. This rectangle represents our crate. And so Fn, and this is Fn, perpendicular to the surface or normal force. And Fg, the red arrow going down, the gravitational force. And since this crate is sliding down the incline, is the kinetic frictional force F sub k of opposite the motion. So we make our x-axis as the incline with plus x going down the incline, and opposite that is negative x. Up the incline is negative x. And so our plus y is perpendicular the incline, up the incline, perpendicular to the incline, plus y. And minus y is opposite that one. So we have here Fg, which does not lie along x-axis or y-axis. Thus, we need to get its components. So components of Fg are Fgx and Fgy. Our incline is 30 degrees with respect to the horizontal. And for the given, the mass of the crate is 100 kilograms. V naught equals 2 meters per second. V final, since the crate stops here, is 0. Xf minus x naught is 4 meters. The displacement of our crate is 4 meters down the incline, and theta is again 30 degrees. So looking at this triangle, Fg, Fgy, and Fgx as sides and 30 degrees here, the angle, we have sine 30 degrees is opposite the angle is Fgx, opposite side over hypotenuse side is Fg, and cosine of 30 degrees equals adjacent side of this triangle with respect to theta or 30 degrees Fgy, over hypotenuse is Fg. Now to write our summation of Fx and Fy by looking at our free body diagram, we can say that summation of Fx, or the sum of all forces along x, is equal to, looking at this figure now, down the incline is Fgx, and that's positive because down the incline is positive, and up the incline is our minus ffk, because going up the incline is negative x, so minus ffk. Then we ask ourselves, is this object or crate accelerating or decelerating along x, since from v naught of 2 meters per second it stops here down the incline, so it is it slowed down or it stopped, so decelerating, thus equals MA. For the summation of Fy now, okay, so we have here plus y is Fn, Fm positive, directed to the positive y. And opposite to that, we can see in our figure the red broken arrow is FGY. FGY. So minus FGY equals, along the y-axis, we know that the object or crate is not moving, it is sliding along the x, but there is no motion along the y, so it is equal to 0. We will now solve for the crate's acceleration or deceleration. Now we will solve for the crate's acceleration. Even if we have a here, ma acceleration, we have no ffk. So two unknowns here, we cannot use this equation right away. So we have to recall our equations when we discuss about horizontal motion with constant acceleration. Since we have the given, so we can use one of those equations. Let us recall those equations. And so, recalling our equation 1.1, 1.2, 1.3 equals Vf minus V naught and 2A xf minus x naught equals Vf squared minus V naught squared, and of course the last xf minus x naught equals Vo Tf minus T naught plus 1/2 AT squared. A Tf minus T naught squared. So T naught is always 0. So let's drop everything, all the T naughts. And here, the given, since the crate stopped, Vf is 0. So let us drop V final. Let us now check the other given. Acceleration is what, or deceleration is what we're looking for. The final is unknown. The final is not given. V naught is given. Okay. Second equation, acceleration is unknown. Xf minus x naught is, we have this. V naught is given. So this is actually the 1.2 equation. Looking now at equation 1.2, we have the unknown A and the rest of the given, all of them are available. So we will use 1.2. Using 1.2, I'll just copy it. 2A xf minus x naught equals negative V naught squared. You want the A, so we can divide the entire equation by 2 times xf minus x naught over 2 times xf minus x naught. 2 divided by 2, that's 1, and xf minus x naught, xf minus x naught cancels, leaving us with our working equation now. We have A on the left So you're solving for this equals negative V naught squared over 2 times xf minus x naught. Substituting the given, negative V naught is 2 meters per second squared all over 2 times xf minus x naught is 4 meters. Using your calculator, you should get an answer of, this is negative. You only square the 2. Okay, so the numerator is still negative divided by positive. So the answer is negative. You should get an answer of negative 0.5, and the unit is meters or meter per second squared. Let us work out the units. So we have numerator meter squared over second squared divided by denominator over meter. So numerator, denominator. This will become numerator times the reciprocal of the denominator. So numerator, meter squared over second squared times reciprocal of meter is 1 over meter equals meter square over meter gives us meter over second squared. And this is a correct unit for acceleration, meter per second squared. This is negative because the acceleration vector points to the negative x-axis or up the incline since the object is slowing down towards the plus x. Let us now solve for letter B. Solving for the kinetic frictional force. FFK between the surface and the crate. Let me go back to our equations, and FFK is here. We have FFK in the summation of Fx. So we use this equation. Fgx minus FFK equals MA. So using summation of Fx, Fgx minus FFK equals MA. We have solved for A and we have the mass. And this is what we are looking for, the FFK, and we still need to determine our FGX. Recalling our trigonometric identity. Okay, going back to our figure. Here we have sine 30 equals fgx over fg. So we will use this one. Sine 30 equals fgx over fg from the right triangle. Sine 30 degrees equals fgx over fg. Transposing this, cross multiply. So fg sine 30 is equal to fgx. So we need to look for fg. So we continue, but fg is equal to the weight equals mg. So fg is now mg mg. This one is now mg. Copy the rest. Sine 30 degrees equals fgx. So fgx is mg sine 30. mg sine 30 degrees. Minus f of k equals ma. So this is negative f of k. We transfer this one to the right side of the equation, and ma goes to the left side. So we have mg sine 30 on the left side, just copy, minus ma equals f f k. We now substitute the values. Substituting now the values, we have mass is 100 kilos times g 9.8 meters per second squared. This is positive because mg is our weight. So again, the sign of g has been taken care of in the free body diagram. Sine 30 degrees. I'm now here minus mass is 100 kilos. Acceleration along the x, we have already solved this, negative 0.5 meter per second squared equals FFK. Executing this using your calculator, 100 times 9.8 times sine 30 equals minus, open parenthesis, 100 times negative 0.5 close parenthesis equals. You should get an answer of 540. For the units, it's kilogram meter per second squared and kilogram meter per second squared. So you can combine the two terms. And so this is it, 540 kilograms meter per second squared, or newtons. So 540 newtons is the kinetic frictional force. We are to determine the mu sub k, or coefficient of kinetic friction between the crate and the surface. So using equation 4.4, we have mu k, coefficient of kinetic friction, mu k, equals f k over Fn. We have already solved FFK in letter B. Now Fn, we still need to get this. Looking again at our figure and the equation which we have made. Okay, here, Fn. Here is Fn. Summation of Fy is Fn minus Fgy. So we solve this, we use this one. And for Fgy, we look at this, cosine 30 degrees equals Fgy over Fg. So Fgy is Fg cosine 30. So Fgy is Fg cosine 30. So we write that one down. Using summation of Fy, Fn minus Fgy equals 0. So Fn, this goes to the right, equals Fgy. But in our triangle, we have cosine 30 degrees equals Fgy over Fg. That's why cross multiply there. Fg cosine 30 degrees equals Fgy. We place this one here. So Fn equals Fgy is Fg cosine 30 degrees. But what is Fg? Again, Fg is equal to, I say but, weight equals mg. All right. So Fg is equal to mg. So Fn is now Fn equals Fg is weight equals mg. Mg, copy cosine 30. Cosine 30 degrees. This is now our Fn. So we now have our Fn. We finish calculating our mu k on the left side of our panel. FFK, the one we obtained in letter B, the value of that is 540 0.40 newtons. And Fn, let's just continue this one then so that we can also have a value. The mass of our object is 100 kilos times 9.8 meters per second squared times cosine 30 degrees. Using your calculator, you should get an answer of 848.70 newtons. I'm using here 2 decimal places. So that's our Fn. Substitute it here. 8 for 8.70 newtons. So divide 540 by 848.7. Newton over Newton cancels. Mu k is now 0.64.